Hello, I'm Will Buick, one of the program managers on the Visual Studio project and build team. Over the last few years, it's become essential for software solutions to work across several devices, platforms, and even services. In this video, I would like to show off a few of the ways that Visual Studio 2015 streamlines cross-platform development. First, I would like to introduce you to shared projects, a new way to share code and assets across platforms in Visual Studio 2015. I will also discuss how shared projects compare to PCLs, and dive into the scenarios that PCLs and shared projects are best suited for when writing cross-platform applications. And finally, I will show off some of what you can do with shared projects with a quick demo. Shared projects are a new way to share code and other assets in Visual Studio 2015. Conceptually, shared projects are pretty simple. They function as a container of files that can be automatically imported into other projects in the solution. Once a project references a shared project, it acts exactly like the shared project's files are its own. This type of project may sound familiar. We first introduced shared projects in a limited capacity in Visual Studio 2013's Update 2 to support universal app development. The paradigm proved to be rather successful, so in Visual Studio 2015, we have enabled shared project support across a much larger set of project types and scenarios. In Visual Studio 2015, shared projects have evolved into a first-class project type. You can now create empty shared projects and link them to other projects with the reference manager. Shared projects are not the only way to share code across platforms in Visual Studio. You may be familiar with portable class libraries from previous versions of the product. Shared projects and PCLs take very different approaches to the problem, and each is well suited for different applications. Shared projects are great for sharing code in a single cross-platform application. Under the hood, Visual Studio treats all files in a shared project as if they were part of every project that references them. This has a number of benefits. Shared projects do not produce a binary. Instead, the code is merged with each project that references it at compile time. Because of this, the shared project can fully leverage platform-specific APIs and access types and assets as if it was part of the project that references it. Static assets such as images and configuration files can also be shared. PCLs, on the other hand, are better suited for creating reusable cross-platform libraries for several applications. PCLs produce a true cross-platform binary instead of sharing code at compile time, and this can better enable distribution. But keep in mind that PCL's code is restricted to the intersection of the APIs exposed by each platform that it must support. As such, some of the shortcuts you can take with shared projects must be abstracted into platform-specific binaries when you're using PCLs. Now that you know some of the background of shared projects, I'd like to show off how they actually work. This solution contains a newly created multi-platform application for Windows Desktop and Windows Phone 8.1. The phone and desktop clients have the same behavior, so all of the business logic can be shared. What I'm going to show you is how to create a new shared project, add it to the solution to share some code. First, we're going to want to create a new shared project and add it to the solution. You'll see it pops in there. And then we're going to want to reference that shared project from both of the client projects, the desktop client and the phone client. So we do that just as you would a normal project-to-project reference through the reference manager. You'll see it shows up here. And I'll do that again here. And one of the things you might notice is it has a different icon. We just want to make perfectly clear that this is not an assembly reference or a binary reference. This is actually referencing the source code in that shared logic project itself. Now, any code that we add to this shared project will basically behave as if it was part of these two projects here. So I'm going to add an existing file that I have here. It's a simple utilities class, basically just a glorified hello world. And I'll open this up and then you can see some of the features of the shared project code editor. So the first thing you might notice about this code is that it actually has two code paths, and one of them is disabled by the preprocessor right now. Up in the upper left-hand corner, you'll see this drop-down menu here. This basically lists all the projects that reference your shared code. And this allows you to set what the editor's context is, and that drives things like IntelliSense. It will know which preprocessor directives are declared to figure out what code path is actually being activated. And I'm going to activate the phone context for just a second so that you can see this. Now, what you might notice is that this is taking advantage of the Windows Phone Platform API. And this API does not exist in normal .NET. So the WPF desktop client doesn't have any access to this. But you can leverage it in this shared code as long as you wrap it in an if-def so that it will not be activated when it's built for the desktop version of the project. Changing contexts also drives IntelliSense. That will all be updated. And one thing you might notice once this starts listing out the classes here, it will actually warn you when you're about to use a class that is not supported on phone or any other context that is imported into the shared project. That wraps up the demo. Hopefully this gives you some insights into how shared projects behave in Visual Studio 15. You can find more information about shared projects and PCLs on the Visual Studio and .NET Teams blogs. There will also be additional documentation in the release notes. Thanks again for watching.